Good day. So here we're looking at the different types of organic compounds we've run into, and I view this sheet as very useful. So when we started this section, we looked at alkanes, alkenes, and alkynes. And we talked about if all you have are single bonds and you have an alkanes and all it has is carbon and hydrogen, then we can use this formula CnH2n plus 2. And it gives you a reminder of how to name it. Okay, we have 3 carbons. Propane has to end in ane because it's an alkane. When we go to an alkene, we've wiped out 2 hydrogens by putting in a double bond between 2 carbon atoms. So in this case, we've given you an example of 1-butene. And notice it ends in ene because it's an alkene. And it has the 2n plus 2 business. Now if we got excited and had 2 double bonds in there, then it's cleverly called a diene. After alkenes, we hit alkynes, and now it's 2n minus 2 because we have a triple bond. That's wiped out 4 hydrogens from what would have been an alkane. And of course it ends in an ine as well. And we have to put the location of the triple bond. Cyclo just means rings. So if we're looking at a cycloalkane, its formula is going to be CnH2n, just like an alkene. Because by biting, basically it's like a snake biting its tail to make the ring, that wipes out 2 positions of hydrogen. And so here it says cyclohexane because we have 6 carbon atoms, and this is one of the simplest ways of representing it, where every corner represents a carbon atom. And every carbon atom in this case would have 2 hydrogens that are not included in that diagram. And no, we don't let you get away with that in this course, but it is wonderful. Aromatics, they're based on benzene, so that 6 carbon ring with the delocalized electrons. So remember, resonance structure says all the bonds are identical, and it has a C6H6 formula for the parent structure, and then we can do things. We can put different branches or maybe halogens on it and come up with interesting names. Over here you see naphthalene, something we really won't encounter in this course. Alcohol, we see R represents a carbon chain and an OH, and that's a hydroxyl group, which can be on any carbon in the chain. So we have to put an address once our carbon chain is 3 atoms of carbon or more. If it's 2 atoms, of course, if we just have one of these, both carbons would be N carbons. And so here we see 1-propanol, so that would be representing carbon 1, 2, and 3. And on the first carbon, there's the OH. Ether is where we've replaced a hydrogen with another carbon chain. That carbon chain can be the same as the other carbon chain, or it can be different. So that's why it has the R and R prime. And then it gives you 2 ways of naming these ethers. This is likely the more common way, or more modern way, perhaps I should say. And so in the second case, you can see that we treated ethane, the 2 carbon branch, is the main chain. And this would have been methyl oxygen, which gets called methoxyethane. Aldehydes, we have a carbon chain. At the end of the chain, we have a carbonyl group. And so propanal is our example here. Aldehyde, al at the end. And 3 carbons, and that carbon's included in the chain. Ketone says, hey, we got a carbonyl group, very similar to aldehyde. It's just not allowed to be on the end carbon. It could be on any interior carbon, just not the end. And since it's a ketone, the suffix is -one, so 2-pentanone. Carboxylic acids we've talked about quite a bit. C double bonded to an O, OH, often represented as COOH, but you have to remember this structure. And the suffix is oic acid, so here we have ethanoic acid. Ester, we replace the hydrogen with a carbon chain, so we end up with the carboxyl group in the middle. And it talks about the YL and the O8. So the alcohol becomes a branch with a YL ending, and the oic acid of the carboxylic acid now ends O8. So here's our methyl, and here's our ethanoate, and away we go. So that's a pretty good review. The only thing that's missing are things like amines, and they're very straightforward as well. But I do think this is a very handy summary to keep in mind.